In this video, we will have a look into matplotlib, which is a plotting library that we can use to visualize our data. Matplotlib offers various plot types. We have the simple line plot, scatter plots, bar plots, and a lot more. This week we will only cover line plots and bar plots, but if you're interested, we might do a section on statistical plotting. But for now, let's stick to the simple plots. Before we can start, we first have to install matplotlib. And for that, we open our terminal and then activate the conda environment that we want to install it in. So right now I'm in the base environment, but I will install it in some other environment. And to install the library, we simply run pip install and then matplotlib. And now we're good to go. To use the plotting functions of matplotlib, we'll import a submodule of matplotlib. And so we write from matplotlib, import that submodule, which is called pyplot, and we give it an alias plt so that we don't have to write pyplot every time. Okay, so what are we plotting? We want to plot the 7 Harry Potter books against their page count. And to create this plot, we simply write plt.plot. Then we give it as a first argument the data, which should go on the x-axis, which is books num. So we write books num x. And then on the y-axis, we have the page count. Running this alone will not give us any output, but we can write plt.show to show the plot. And this opens up this window here. On the bottom, you see some tools that we can interact with. For example, there's a lens, which allows us to zoom in into a certain part. And we can also click on here to move around. If we want to undo any of the changes, we click on the back arrow. And we can also save our plot as a PNG file. Right now, our plot is lacking any kind of description. So if we were to pass it on to someone else, they would wonder what this plot actually stands for. And so to fix that, we can give our plot a title and also label the axis. For the title, we write plt.title and then give the title as a string. So we can write page count of Harry Potter books. And we can label the x-axis with plt.xLabel. And here we pass the string books. The same works for the y-axis, so we type plt.ylabel. And here we have the page count. And if we now run the code, we have a plot with a title and also axis labels. So here books and here page count. Okay, let's add another line to our plot. So some new data. And what we add is the number of minutes in each of the Harry Potter movies. So for that, we go into the snippets file here and take the movie minutes. And then we simply add another plt.plot. And the data for the x dimension stays the same. But now on the y-axis, we have the movie minutes. And if you run that, we now have 2 lines. The problem right now is that someone that's not familiar with the code will have no idea what the lines stand for. And for that, we can add labels to our lines. So in the plt.plot, we can pass the label pages, since we're plotting the pages here. And then for the minutes plot, we add the label minutes. And we should also change the y-axis label, since we're not only plotting the page count, but also minutes. A better solution for that would be to have 2 y-axes, but we'll not go into that here. So if we again run the code, we would expect our lines to be labeled, but there is no label. And that's because we first have to call plt.legend. And that will add a legend that makes use of the labels. So if we run the code, we now have a label that indicates what each of the lines stands for. So that's our pages and that's our minutes. Besides the label, we can also pass a lot more arguments to the plt.plot. For example, there's the color argument. Well, let's say we change it to red. And now the pages line is red. You can check the actual matplotlib documentation if you're interested in customizing your plot. One quick way of changing the whole appearance is plt.style. And so if we add the plt.style.use into our code and give it as an argument one of the available styles, then the appearance changes to that style. To find out about the different styles that we can use, we can print plt.style.available. And then it lists us all the styles. Okay, now on to bar plots. To go from a line plot to a bar plot, we simply exchange the plot with a bar. And this gives us this plot here. The tricky thing with bar plots is that the bars can overlap. And while this is not a problem if the bars in front are smaller, if we were to change the plot order, then one part of the data is hidden. And so to fix that, we add an offset to the x value of our data. Right now we're using as x values for both minutes and pages this list here. And so all the bars are centered around the respective numbers 1 to 7. So maybe let's write first explicitly what we want. So let's take this list here, and then for minutes we want to add to each x value some offset. So maybe 0.1. Let's do it for the first two values. And now we can see the minute bars are slightly shifted to the right. Of course, this manual editing is not really convenient. And so instead, we have two options. Either we use list comprehension or we use NumPy, which is an external library for numerical computing. Let's start with the normal Python solution first. So we take our x values and then we write as a list comprehension that we want x plus 0.25 for x in our x values list. We close the brackets. And now all of our bars are shifted. And so we can do the same for the pages bars, but instead of adding, we subtract. And now all the bars are shifted, so pages to the left, minutes to the right, but it still doesn't look nice since the bars are too wide. So what we can do is specify a width argument, and we give it the value 0.4. Same for the pages plot. And now it looks better, but it's still a little bit hard to tell which bar belongs to where. And to fix that, we'll move the bars that belong to each other closer together. So essentially we'll reduce the offset. And so we go from 0.25 to 0.2. And now we have a nice looking plot. Okay, now onto the much simpler NumPy solution. So first step is we import NumPy, and we also give it an alias, which is np. And NumPy provides us with arrays, which are very much like lists. The cool thing is that we can very easily perform element-wise operations. So let's initialize our array, and we'll do that with one of NumPy's utility functions called np.arange. And that works very much like the normal range. So we give it a start and a stop, which is exclusive. So this will give us an array with the values 1 to 7. So we match our books x, and we can comment that out and also print the books x. And we see we have the values 1 to 7. And now we can easily do, for example, plus 1. And now we have the values 2 to 8. So all of them are incremented by 1. So instead of writing these long list comprehensions, we can now just write our x data and then add the offset. So we write plus 0.2. And instead of that, we write minus 0.2. And this gives us the same results, but with easier to read code.